So good morning, everyone. My name is Nicolas, and today I'm going to talk about fine-grained reactivity. But before we start with what is fine-grained reactivity, and without a compiler, let's first of all understand what is reactivity. I found a definition for it, but unfortunately, I'm in a React conference, so I'm not comfortable with putting the definition. It's coming from another framework, but I need to take it. I think it's quite good, this one. And the definition is the following. When you modify the state, the view updates. It makes state management simple and intuitive. It's coming from the Vue.js website, and I think it captures what it means to be reactive. To be reactive means that you have at some point some kind of display target. In our case, I would say the DOM in some cases, and it's a function of the state. I would say this can be summarized that way. So the first question we should ask ourselves when we are using React is, first of all, is React reactive? Yes, no. So in order to answer that question, I will just take a very simple example. This example will be made of 3 countries. So you can see, like, the first one is the first row, the second one, the second row, and obviously the third one is the third row. We can increment, decrement these countries, and at the end, we have the total of all the countries. Pretty simple app, pretty common app, I would say, for example. And so if we want to build such application, you may have come up with something like that, like an application which will be responsible to instantiate 1, 2, 3 countries and a total. Now we want this application to be interactive. So we'll need to put some states somewhere. So I will just put a few states within countries so that you can just directly play with each of these countries. You can increment each of them, decrement each of them, and see the value of them. But as soon as we want the total to be like the real total of all the values, we need at some point to have these states directly within the total or access the states from the total. So a common way to do that will be to move the state higher in the tree. In other words, the state will lie in the app component, and everything will be drilled down to the root component, to the leaves component, so countries and total. If we just look at how we could have developed such application today, we may have come up with something like that. So we have just the app component in our case, because I will say it's the most complex piece of code. In this example, the app component is responsible to create 3 states, and each of these states will be forwarded to each country. So the first country is taking the first value, the first state, and a setter function. Same for the second one, and so on and so forth. And you can see the total, which is just made of the 3 values. On the right of the screen, we can see the application running, and I'm playing with it. So the video is just showing that we can increment, decrement stuff. Anytime I increment and decrement, you can see that the total is being updated, so it's reactive. So first question, it's reactive. And I enabled something interesting in React DevTools, which made us able to see what is being re-rendered. In React, being re-rendered just means that your function, so this app, for instance, or the function for counter, or the one for total, has been called. And what we can see there is that anytime I'm incrementing one counter, all the other counters will be rounded again, the total also, and the app also. So first time I saw that, I was like, what the hell is doing React? It's like crazy. It's not what I would have expected. I would have expected something a bit, I would say, clever. And so it was 5 years ago, and I was a bit sad. But recently, I discovered that there will be some kind of compiler. So I was like, yeah, maybe the compiler will save my life. And so for this talk, I gave a try to the compiler. And it's actually pretty great. So we can see there that whenever we click on an increment, whenever we increment the value of a counter, we have the counter which is being re-rendered, which is expected, the total, plus the app. You can see the general overlay on top of the app. So the app has to be re-rendered, the counter, and the total. But it's way better than what it used to be. And because I like to go in details when I'm using a technology, I wanted to see what's behind the scene, what was done by the compiler. I just went quickly through it. So this is the code of the initial application, the one I showed you right before. And if we toggle on the compiler, again, that stuff, we can see that the compiler is doing lots of stuff. And when I say lots, it's a lot of things. So first time I saw that, I was like, maybe the compiler is too much for me. Not sure, maybe. It's your choice. I think it's a good option, honestly. But just to tell, maybe it's good to know. But it doesn't answer to the main question, is React fine-grained reactive? was it fine-grained reactive before, and is it fine-grained reactive today with the compiler? I took another definition from yet another word. It's coming from Solid.js, and the definition that they use for fine-grained reactivity is, in a fine-grained reactive system, an application will now have the ability to make highly targeted and specific updates. What it means for our system is that we should expect only the counter that has been impacted, the one I clicked on, plus the total to be recomputed. And if you think about what happened before the compiler and after with the compiler, none of them are really fine-grained reactive today. I mean, with that definition in mind. So we'll have to do some work. We'll have to think about, I mean, if we want to do something which is fine-grained reactive in React, maybe we have to do some extra work. And this is the aim of this talk. I haven't really introduced myself, so my name is Nicolas. I'm the author of a framework called FastCheck. Maybe some of you have heard of it. If you don't know it, maybe you should check out and check it. It's available on NPM. And today I want to tell you what we did at Pigment. At Pigment, we are a business planning company, and we had to optimize the reactivity for real performance issues. So I will tell you a little bit more how it worked at Pigment and what we had to achieve. At that time, when we started at Pigment 5 years ago, nothing, I would say, there was not that much ready to do fine-grained reactivity, so we had to come up with some ideas, some new ideas that we implemented that I will show you in the slides. There was no React compiler, no Zustand, no Recoil, and no other solution like that. But before we can even see how it works at Pigment, I would say, I want to tell you the journey that we take before reaching that idea. And the first thing that we did was to try to understand what make an application a bit more reactive and why it wasn't reactive. So we took back the examples, the very simple example I showed you initially, this one. And we asked ourselves, what is going on? What is explaining that everything got re-rendered all the time without the compiler? And if we think of a user clicking on the third button, for instance, so the third button is green stuff there, it will change, we can change the value of this green stuff to something else. So let's say we change it to something red. Whenever in React, whenever the state of a component changes, React has to re-render this component. In other words, because the state is within app, whenever we change the value of this state, React will just re-render app, which is normal. This is, I would say, like part of the contract with React. At this point, React hasn't called the function. It will call it. So it doesn't really know what's the state for counter and total. Maybe they have gone. Maybe they are still there. So it needs to call app in order to know that. Once done, it will know for sure what's the status. And in our case, counters are still there and total is still there. But there is a second rule in React. Whenever a component re-renders, React has to re-render all its children. By children, you should understand anything that has been instantiated by this component. In other words, for application, React will have to re-render counter 1, counter 2, counter 3, and the total. And this is why everything was blinking on my original video. This is the reason why React is just re-rendering everything. It's part of the contract. So it's normal, it's expected. I just need one last case because it wasn't there in this example. Maybe some people are using context today, use context in React. If you are using context, there are some troubles with context and states. Usually you can consider that the value of your context can be seen as some kind of state within each of the components that are using the context. I think it's the best way to understand it. I mean, anytime you pull something from the context, if the value of the context is changing, you can see that as if your component got updated itself. So it will have to re-render and so on and so forth. So we have the idea. We know why it wasn't working. I mean, we know why everything was re-rendering, but we need to optimize it. So we have this code. Today, we are lucky enough because we have the compiler, so we know some ideas about how we can optimize stuff. The compiler is doing some interesting things, so maybe we can do the same. Maybe we can just use the compiler in the future. But today, not available, so maybe we need to do it ourselves. And what is doing the compiler is, first of all, memoizing component. It's not doing it that way, but the idea behind the scene is more or less the same. So one thing we can do is to memorize components. When we do memo, when we do use React memo on top of a component, it means that the component will not have to re-render if props are the same from one render to the other one. In other words, we can cut some re-render process. We can cut the branches. And so we just update our code that way, just a single line of code, and we can just give it a try. So we take the same example, and we will just give it a try. Was it enough? First thing I want to say that contours doesn't have only one property. They have two properties, one which is the value, and the second one which is the increment function. And if you see my point, when we press the increase button in the app component, so we change the state, so it moved from green to red as before, we don't know at this point if contours will still be there. And when we know that, unfortunately, we have a small problem. All increment functions have changed, because in the app function, we are not providing stable version of the increment function. So it means that for React, everything has changed. So we just defeated the memo. Memo is useless in our case. It's not working. We need something we need to go even further to make it optimize. So we take back this code, and you can see the problem is like this increment function at the bottom of the slide. And what we need to do if we want to optimize stuff and to get on par with what React compiler is doing more or less, we need to use callback. And with all of that, we are able to have exactly, I would say, what is doing React compiler, but we did it manually. So it's a bit of work, and it's simple for this case, but in other cases, it would be a nightmare. But if you remember the previous slides, there is still a problem. React compiler was not that fine-grained reactive. It's great, it's doing a lot of things, and it will optimize lots of applications, but maybe it's not enough for some context, for some application. So let's discuss of Pigment. So what I showed before was just initial, I would say, like initial investigation on React, just in order to understand what was the problem, where is the key problem, what can we do, what can't we do with usual primitives without doing something extra. So at Pigment, we are building dashboards, and dashboards are made of plenty of data. We can have charts, like this bar chart, pie chart, and graphs. In the graph, you can see that we have formatting, we can have selection, we can have user input, many stuff. All this stuff are real-time data. Everything is real-time, meaning that if someone in another room is playing with the data, this is financial data. In my case, it's just my chicken, so there is no financial data. You can take pictures, no problem. So it's just the number of eggs in my case. So no one is playing with that application, so we are safe. But in normal application, there will be multiple users at the same time, and maybe they will input stuff at the same time. So they will see figures being updated, graphs being updated, and maybe several of them at the same time, just because of one click, just because of one change in one cell. The thing there are pretty limited in my example. It's just my chicken. I just had 3 of them, so pretty limited. But if you think of a real application, like a real business, it's not a matter of free stuff. They have several employees, they have several products, and it doesn't fit in the screen. And we can have stuff reaching millions of cells. I would say even hundreds of millions of cells for some of them. And the last thing is that we do have to share some things between components. The green stuff is just a label, actually, but this label is the same in all components. We don't want it to be unsynchronized between each graph, each table, each grid. So we have to put them in some kind of shared cache that can be reused everywhere, and this cache is real-time too. So if someone is changing Bernard Meder, which is a name, into something else, it will be updated everywhere at the same time. And so we used context for that one, which was possibly one part of the problem initially. As I told you, it's not something that is great for performance in some cases. And this is what we have today. So this is a grid. This one has been formatted with extra formatting rule. I pretty like to put the eggs at the end, etc., plus the colors. And what we can see in this video is that whenever someone, not me, someone else, is changing something within this data set, we have only the cell that has been re-rendered. Only the cell or only the header. In some cases, you will see that there is only the header. In some other cases, it's only the cell. And whatever the update, if it's a formatting change, if it's a value change, only the specific things will be updated on screen. No render for all other cells, which is what we want for fine-grained reactivity. So let's see together how we did that at Pigment. In order to understand that, we'll take this example. not that pretty. This one is too pretty for me. I did a very simplified one, which is horrible, actually, but you will see. But let's first of all think about this one. In this one, we are defining what people may know of if you have been using Excel, for instance. It's called a pivot table. A pivot table is just made of a set of lines. So you give a set of lines in a CSV fashion, I would say. Each line is defining what are the headers for the value and the value. And we are passing also I would say the configuration of the grid. In our case, the configuration is made of what is the kind of chicken, Sussex or Azure, and what is the name of the chicken, Bianca, Bernard, or Jasmine. So this is for columns, and for rows, you have the years. And this is an example of the data that we could have filled to this table. Just to let you know, the data can come in any order. There is no specific need to have the data in the order of the cells. It's just a configuration. I mean, the data is just the data. The configuration in this case is just columns and rows. Something important to note before we move to the next slide is that if we look at Sussex, for instance, Sussex is a kind of chicken, but there are 2 chickens with that kind in the farm I have. And so Sussex is spanning on 2 headers. There's also something interesting, like if we think about the first column, we define at Pigment what we call a pass. The pass is Sussex plus Bianca. It's like what are the ancestors for this column? What are the ancestors for these rows? Just to give you a little bit of wording so that we better understand what's going on afterwards. This is, I would say, a simplified version of the code. I will not dig into all the details of the code. There is the version there, React comparison, / React comparison. I would just zoom in some details. So first of all, the props, they are the one that we thought of, like lines plus configuration. Configuration is just what are the columns, what are the rows. Then, based on this configuration, we can just compute the headers. So what are the headers for the first level? It was Sussex plus Azure, for instance. Then we can compute the span. I told you about the span, the thing that said, OK, the first column is spanning on 2 columns. So this is what we do with that extract span stuff. And the last thing is about pass. We need to extract what is the, I would say, what is the set of ancestors for the first column, the second one, and the third one. Based on all of that, in this implementation, we are able to render headers and cells. In the real application at Pigment, everything has been virtualized. So this is the reason why we need to pre-compute everything, to know in advance what we need to display or not. But anyway, the code is, I would say, like the idea behind the scene is pretty close to this one. Now that we have this code, we can just connect it. So in my case, I would just connect it with a rather simple application. This application is made of a set of buttons, and the buttons will offer 2 options. Either you refresh the line, so you just read the data from the backend, either you increment the first cell. Nothing special. Then you pass the lines to the grid, and we'll see what happens. So this is our example. I told you it was not pretty for this one. I did it quickly, but there you can see that whenever I click on refresh data, everything has to be rendered. So it's not at all fine-grained reactivity at all. But we are expecting something like that. I mean, it's normal. We are changing the state at the root, and everything has to be rendered. It's normal. So then when I did the slide, I was like, yeah, but React compiler, we can use it. I mean, it has been done for that. I mean, it's the purpose of React compiler. So we can use React compiler. Actually, it does the same. I mean, you can refresh the data, no change, nothing. Everything has to be rendered. You can refresh one cell. Obviously, everything will compute again. So it's not yet doing fine-grained reactivity on this example. And maybe it's great. I mean, we probably need to do something special for these kind of cases. And so let me explain you what we did at Pigment. At Pigment, we were pretty happy with like normal primitives of React, like useState, this one. But the problem of useState, as we've seen before, is that whenever you change a state, the component has to re-render. It's the first rule I gave you. So we need something else. I mean, useState is good. The signature of useState is pretty cool. So what if we could replace it by something else, like just useShell? I will just explain you what is useShell about. So useState is something simple. It's taking an initial state and returning this value plus a setter. When you play with the setter, it updates the value, plus it asks React to re-render the component, plus the children, etc. Our useShell will be a bit different. Instead of returning an unstable value, it will return a shell, and the shell will hold the value. So you call use shell with the blue bubble, and then at the output, you will get a shell with the blue bubble within it. When you set the value, you keep the shell stable, so there is no change for React point of view, but you change the content of the shell. So you put the green one in this example. How could we implement that? So the signature, this is like the TypeScript signature. We take an initial value. In our case, we decided to take what is called behavior subject. It's something coming from RxJS for people that know about RxJS. It's something that you can subscribe to, so you can ask to be subscribed to any updates of this, I would say, shell. I will refer to it as a shell. And you can, when you build it, you will need to provide an initial value. You can also get the value in a synchronous way. So now that we know what will be our shell, we can just create it. So we do a use state, we instantiate a new behavior subject with this initial value. Nothing special there. Then we define a setter. The setter function will just be responsible to put the value within the shell. So it's doing a dot next, because in order to update the value of a behavior subject, we need to do dot next, and we return it. So at this point, we are pretty happy. Signatures look great, but if you are using TypeScript, you may have a problem at this point, because like lines are not anymore the right type. So you need something else. These 3 lines of code, what we do in these 3 lines of code is like, I would say, intermediary steps for the computation. We actually don't need them to render the stuff. So what we want is to continue having shells. We don't want React to know about the computation. So what we will do there is to take a shell and transform the shell to another shell. We'll see later how we can extract the value from the shell, but at this point, we just need to take the shell, extract, and move the value to another shell. So we introduce a new helper. This new helper is taking a transformation function, in my case, something that goes from blue state to green state. It's taking the shell. In this example, this is a shell holding a blue value, and it's creating a new shell. And this new shell will hold the transform version of the value. How can we implement it? So we need to create a shell. So we use useShell. useShell will be provided with the initial value being the result of the value of the existing shell transformed with the transformation function. Now we need to watch for updates. So we need to subscribe to the original shell in order to know whenever it changes and to connect the new shell to it. So what we do there is that we subscribe to the initial shell, and whenever it changes, we just call the setter of our new shell, and with the transformed value. And that's all. We have a new mapped shell. So now that we have even more shell, at some point we need to render something on screen. At this point, React is unaware of everything. It doesn't know what happens. Everything happens under the scene. But at some point, we need to put the value somewhere, because we need to be reactive. So we have the state, but we don't have the DOM being updated. So we need to put reactivity. And the last piece is to do things like column defs. We need the value at this point. How can we do that? So we can create a shell, obviously, but it's not very useful. But we create a shell. And then we need a new helper, which is useWatch. This one is pretty critical in this case. What we will do in useWatch is take the shell and make it as a real state, so that React will be aware of the change, if any, and it will be able to be called to re-render the component and all the children. So useWatch is just taking a shell with a blue value in this case and extracting the value as a state. The implementation is, I would say, rather simple. We are using a built-in of React, which is called useSyncExternalStore with 2 helpers, subscribe and get snapshot. Subscribe is just subscribing to the shell and asking to be notified whenever there is a change in this underlying shell. And get snapshot is basically reading the value in a synchronous manner through the shell. Based on that, we can connect everything and see if it works. So this is the final result. So this is with the code I've showed you. And you can see, first of all, that when we refresh data, there is no data change. So obviously, nothing has to be recomputed or re-rendered. And we can see in the screen that, or maybe we cannot, I don't know. But for refresh data, nothing has been recomputed on screen. Nothing is highlighted. When we click on update one cell, only this precise cell has to be recomputed. And this is what we see there. So we achieve fine-grained reactivity. I just want to give you a last thought about this one. I am running out of time. But something important is beware of early optimization. We did that because it was required and requested for performance reasons. But usually, you probably don't need to optimize your code that way. It's probably depending on what you are doing, what are your needs, etc. So beware that optimization is probably worse than not optimizing in some cases. And that's all for me.